Hi there, this is exercise 11C, finding the area of any triangle, but a bit more than that. It also links with a couple other bits and bobs we're doing. So I'll crack on with this. So exercise 11C. Starter for you, this is just a reminder. I'm sure you can do these. This is finding, well, one's finding a side, one's finding an angle using SOHCAHTOA. I'll put the answers up, make sure you can do them, make sure you can get them right. So they are the answers, and hopefully you're okay with this. I want to prove for you the formula which we saw actually a couple of PowerPoints ago. It was in exercise 11A, and it was a proof of the sine rule, and it relied on the formula I'm about to give you. So if we just run through it, notice the fairly standard now triangle for labelling wise in terms of the C's opposite, the A's are opposite, the B's are opposite, and the big letters represent angles and the little letters represent sides. So we're going to draw a perpendicular. Perpendicular is a right angle from B down to CA, and there it is. And you notice it now has this height shown. And from this height shown, we can therefore say that the area of this triangle, remember the area of any triangle, is the half of the base times by the height. And in this case, the h is written as that, and the base of this triangle is b, so that's why it says half of b times h. And a bit of trigonometry in terms of just working out what the h is. So the sine of this angle is the opposite over the hypotenuse, and remember we're using this because this is a right angle triangle. That's partly why we drew this line down here. So that shows over here as h over a, and obviously that allows me, I want h over there, you see, so the a can move over there, and when I move it over it just becomes a times, and I get a sine c as h, and now this can go and this can take its place. So if I substitute it in, I get a half BA sine C, but written better as a half AB sine C. So the area of any triangle for this angle is a half of the AB times the angle, sine of the angle between. Notice the A and the B. Now I talked about snappy crocodiles the other day. Notice the A and the B are either side of the angle that we need. So if you have that kind of situation, it's very much like the situation you need for the cosine rule. If you have this situation where you have two sides and the angle in between, you can work out the angle of the triangle. Letters don't matter particularly. So if I look at this one, I want the area of this. Oh, the very first thing to note is I've got two sides. Perfect, perfect. But I just said you need the angle in between them. And this is why this is a good example of the way to do it. So that's 36, that's 80. Between them, they make 116. Which sounds to me like 64 left over, and I need that 64 if I'm going to work out this area. And now, of course, it's simply area equals a half times the 8 times the 7 times sine 64. Just type it in, doesn't need to be particularly... oops, I missed it. So, by the time I get 25.1. Oh, 25.2, yes it is, 25.2 if we round it properly, so 25.2, and notice it's square centimetres. So that is fairly straightforward. Now this is the complication I was trying to refer to. You do get sometimes circles, and you get triangles drawn from the centre of that circle, within the circle. And of course the critical thing about this is the radius is the same no matter from where you go, as long as you go to the circumference. So that distance from R to A is, from C to A is R, and the distance from C to B must also be R. And for that reason, we effectively get a slightly modified formula. The formula is meant to be a half AB sine C, and now the A and the B in this case are both R, and I've got the angle now is theta. So I've got half r sine theta, and it doesn't surprise you to learn it's a half r squared sine theta. So this is an important formula that we're going to need. So a couple of questions then. So this first one, find the area of this. I'll just do it for you. This is someone, ideally you'll probably pause the video and then see if you can do it, and then see if you can get the same answer as me. So here's me doing it. I'm going to get a half area equals, sorry, a half of, well, again, wrong angle. I'm told, and I mean, usually, I'll be honest, you get told the right angle, the proper angle, the one you're going to use. But because I'm trying to test you, I've deliberately not done that. 36 and 28, what's that make? I'll make that 64. 64, yeah. So is that just the exact opposite of what we had before? Now this makes this 116. So it's a half of 9 times the 12 times sine 116. Okay, typing that in. And I get 48.5. 48.5, there you go. Here's a second one. This is the slightly less obvious one, but it's fairly straightforward once you suss it. So we've got a circle, that's a radius for OX, that's an R, but by definition, if that's 4, then so is this 4. So my area on this example is a half of 4 squared, and that comes from this factor, half R squared sine theta, times by sine 122. So we keep on getting the same angle there. Or is that just my imagination? 0.5 times 4 squared times sine 122. And I get 6.78. It all seems very straightforward. There you are. There are some slight complications on this. Now that I haven't got any on here, but what I'll do is I'll show you what the kind of complications you can get on this. I seem to have lost my pen. Let's go back. And I'll just show you this. Sometimes you get questions like this, and they want this area. So this involves a slight sort of addition to what we've been doing, and we'll come on to this later on. This, incidentally, is called a segment. That little slice of the circle. Whereas if I wanted all of it, including the sector bit, the segment bit around the edge. So if I want all of that, which I've coloured in, now it's called a sector. So the big bit is called a sector, going to the middle, the centre of the circle. And if I just want that little slice of it, that's a segment. That's worth knowing for next time. So anyway, your job is to do the questions for exercise 11C. Any problems, let us know. All the best.